Hello, this is FlippedHarber for Algebra 2. In this video we'll cover section 6.4, factoring polynomials. Our objectives for this lesson are to use the factor theorem to determine factors of a polynomial and to factor the sum and difference of two cubes. The outline for this video will start with the factor theorem. We'll be determining if a binomial is a factor using substitution as well as synthetic division. We'll take a look at factoring by grouping, and then we'll end by factoring the sum and difference of cubes. The factor theorem, which really is the binomial factor theorem because it tells us if a binomial is a factor of a polynomial, says that for any polynomial, a binomial x minus a is a factor if and only if p of a equals 0. That means that if we plug in the number opposite the number with x into the polynomial and we get 0, then that binomial is a factor. So I know that x minus 2 is a factor of the polynomial p of x equals x squared minus x minus 2. So that means that when I plug in 2, I should get 0. And the reciprocal is true. If I plug in 2 and I get 0, that tells me that x minus 2 is a factor. This relationship goes both ways. Now additionally, I know that if I plug a negative 1 in, I also get 0. So that means that x plus 1 is a factor of the polynomial as well. Now I can use this to determine if a binomial is a factor. All I need to do is plug in the number opposite the number with the x to see if it's a factor. So here I'm going to determine what is p of negative 4, because that's opposite the number that's with the x. Always plug in the opposite of the number. So I'm going to find p of negative 4, which means that I just simply plug negative 4 wherever there was an x. In this case, I get 444, a long ways away from 0. So that tells me that x plus 4 is not a factor of the polynomial. What about x minus 2? Is that a factor of the polynomial? Now here I'm going to do it a little bit different way. I'm actually going to use synthetic division to find out. And this is going to tell me whether it's a factor or not by looking for 0 for a remainder in the synthetic division. So I set up with my corner block. Remember, we always put the number opposite the number with the x. So since it's x minus 2, I put a positive 2 in the corner block. I have my coefficients lined up. Now, why are the zeros there, you might be wondering? Well, I don't have an x cubed term in the polynomial. So I account for that by putting a 0 where my x cubed term would, or my x cubed coefficient would be. The same thing with the x. I want to make room for that x term, so I put a 0 for the coefficient there. Okay, so let's do the synthetic division. We drop that first 2 straight down. So this 2 goes straight down, and then I multiply and add, multiply and add, multiply and add, multiply and add. So I do get a 0 here for the remainder. So that means that yes, x minus 2 is a factor. Now let's take a look at another process called factoring by grouping. Now this is pretty much just a special case. They're going to tell you to factor by grouping, or if you see 4 terms together, you should probably try factoring by grouping. So if they tell you to factor and there's 4 terms, you might as well try factoring by grouping. Now what you want to do is start out with the polynomial in standard form like we have here. Standard form meaning that we have our highest power first and then it goes down from there. And then I just simply group the first 2 terms and the second 2 terms. Now notice I used addition here. I could have factored out this minus and made it minus 4x plus 12, but I like to have a plus in there. Now what I'm going to do is factor anything I can out of the first set of parentheses and factor anything I can out of the second set of parentheses. Well, out of that first set I can factor an x squared. Out of the second set of parentheses I can't factor out any x's, but I can factor out a negative 4. Now you'll notice you're doing this correctly when you see the exact same thing in the parentheses. So now I factor out the x plus 3, and I'm left with x squared minus 4. Notice x squared minus 4, and then my x plus 3. So that's how we factor by grouping. Now the next two factoring methods are very special case scenarios. When you see a sum or difference of cubes, this is how it factors. Make sure you write these down. Now, this is going to be a sum of cubes. How do I know that? Well, I need to recognize that 8x cubed is a cube and 27 is a perfect cube, and obviously they're being added together, so this is going to be a sum of cubes. Now, it's not going to be real obvious probably to you right away, but this number in front of the x cubed needs to be part of that term that's getting cubed. So 2 cubed gives me this 8. So I need to write it like this, and 3 cubed is my 27, so I want to write it like this as well to make it easier to plug in. So I applied the appropriate equation. Since it's a sum of cubes, this is how it gets plugged in, where it's my first term plus my second term, no cubes, then my first term squared minus my first term times my second term, and then finally my second term squared. I always want to simplify, and I'm all done. Okay, so that's it for this lesson. I'll see you in class, and I'll see you online.